credit is helpful to you. Make sure that you sign up for that. There's a QR code on the sign-in sheet, and and make sure you just make eye contact with me, and I'll get your A+ for you. When you have questions today, wait for me to get to you with the microphone. We have some friends online watching, and if you're online, please use that questions link. But we'll wait for me to get to you with the microphone so that they can hear what you're asking. And in terms of announcements, thank you to all who helped or participated in or showed up for or sent kids or whatever to the Virginia Tech Science Festival this past weekend. It was a fabulous success, and I'm grateful to everybody who helped with that. At this point, I'm going to turn it over to the team. I'm excited for this one. This is one of my favorites because we're taking something that we were going to throw away, and we're going to turn it into something that is useful. Turning it over to y'all.
Good morning, everyone. Thanks for joining our presentation. Before I start this presentation, I'd like to thank ICAT for supporting this project, funding this project, and also continuously supporting our project by providing opportunity to host a workshop session in Amazon headquarters and Torpedo Factory. Our project is called Sustainable Art Painting, Turning Food Waste into Pigment. Before we start the presentation, I would like to introduce my team members. There's myself. My name is Yoonjung Choi. I'm an assistant professor of industrial design. Hiromi, she's gonna co-present with me today. She's from School of Visual Art. Young Kim, he's not here today, but he's associate professor from Sustainable Biomaterial. Brooke Kennedy is also from industrial design. He's a professor. And also we have 3 key students who's been involved in this project for a long time, but then they all graduated. But I'd like to acknowledge them. They're Avery, Farida, and Camille. So our project is really looking into the issues of food waste that's been produced in the K-12 cafeteria, school cafeteria. How can we create value-added products by transforming food waste into pigment? In this case, food waste, we particularly focused on fruit and vegetable waste and pigment to be used in art education to increase the awareness of recycling behavior. So to give you a little bit of background information, so in United States, school cafeteria produce $5 million worth of food waste every day, and 19% of this waste comes from fruit and vegetables. And equally, paint that's been used in art class itself is very toxic. Most paint that's been used and is made from the synthetic pigments are made from ambiguous, non-renewable petrochemicals, and petrochemicals are made from gas and oils. And if you're looking into the making and production process itself, is very toxic and have huge environmental impact on the waters and also the air qualities. And when the paint has been finished and washed down the drains, after washing the paint itself, it can actually create more damage in the water stream. And also the paint itself, when it's been dried, it's actually causing a lot of impact on human and animal health because all these dried chemicals are released into the air and having our health impact as well. So paint pollutions are actually really big. There's 1.9 million tons of paint end up in the waterways every year. This accounts for 58% of microplastic in the ocean. Paint microplastic in the oceans are equivalent to 100,000 plastic bottles. So if you think about what happened to the kids' paintings, for my case at least, I don't really keep all the kids' paintings. So a lot of them are being thrown away. Only keep the something which has gotten more meaningful. And sometimes I take photos when a lot of them are thrown away. And then because it's painted with petrochemicals, it's incinerated. It's been through that process and released the CO2 emissions and also creating a huge impact on the environmental air qualities. So olden times, if you look at what the paint pigments are made from, we used to use natural resources like indigos or longwoods or charcoals, etc. All the natural resources used to be our painting pigment materials. So the natural itself, especially like food waste itself, has a potential to create a pigment. So according to Ellen and MacArthur Foundation, what is food waste? It's two types that we can divide, categorize. One is uneaten edible food, and another one is food byproducts. So uneaten edible food is food that's been edible at a time and it was thrown away. And then food byproducts is the secondary products derived from the manufacturing and processing of a primary food products such as peels, leaves, and stems, etc. Based on our research, we found out there are certain fruit and vegetables are wasted in a school cafeteria. There are carrot sticks and orange peels, blueberry red onions, spinach and corn husk, and cucumber and lettuce. They are the main waste has been produced in the K-12 school cafeteria. And those can have a potential to produce a pigment. The carrot stick and orange peel, which contains carotenoid, produce orange pigments, and also blueberry and red onion peels contains anthocyanins, which have the potential to produce red and purple pigment. Spinach and corn husk, which contains chlorophyll, has a potential to produce green pigments. But in our case, we excluded lettuce and cucumber because this contains too much water and it doesn't really produce that much pigments of it. In our research, we went through three major processes and methods to extract the pigments. As you can see, sorting is one of the most important part of pigment extractions because it's the first step to recognize and identify the color itself, and it's one of the challenging steps as well. So, but in any cases, sorting was the first step we had to go through, and then first process we went through a sorting, and then we add solvent, for example, asphyl alcohols, and then we went through the filtering process, and we tried to evaporate the alcohols afterwards. And the second process we went was again sorting by colors, and then we used the juicing machines to extract the pigments, the key elements, and then we used the filtering process, and then we used freeze dryer to evaporate all the waters, and then that become the powder format, and we grind it by hands. And then third method we went through was again sorting by colors, and then we add water to boil them to extract the relevant pigment, and then we went through the filtering process, and again we used the freeze dryer, or sometimes we used evaporating method using our developed tools. So I'm going to show you a little bit more details about the what tools we used to go through these processes. For the first process, we collaborate with sustainable biomaterial using a suction extractors, and it was a really good result using this process, but the only thing was really expensive tools to purchase it, and also it wasn't really safe for K-12 kids can't be more using these tools unless you have a trainings and going through lots of safety regulation procedures. So we had to move on to the next method, which was using a juicing machine, which was more accessible to children to be used in art class, and also it was a little bit cheaper and more cost-effective. So for second method, we went through sorting. As I mentioned, we had to do color-coded sortings, and then we used juicing machine, as you can see on the top pictures, using juicing machine to extract the relevant key pigments, and then evaporate waters by using the freeze dryers. And then we mixed that with gum arabic as a binders. So the powder format has been produced through using the freeze dryer machine, going through juices and also the freeze dryer process. And so those are the types of formats that's been produced using the second method. And then with that powder format, we participated in a science festival to understand students' reactions and if they have a better understanding of the life cycles of food and also recycling behavior, which was really positive. Kids really enjoyed making a pigment using our powder.
You can add another couple scoops of orange pigment on top of that if you'd like. You can get it a little bit bright.
modeling behavior, and really positive, and they were really proud of their own paintings as well. And the third method we went through was boiling method, which was adding a water to certain waste we collected. And then as an industrial design team, we created a series of tools to facilitate this process much more accessible and portable way to use in the art class. So one of the tools looks like a French coffee press inspired extractor, which helps to boil them and then filter them through by using a plunge, and helps to really extract the pigments, water pigments. And then using these machines on the right-hand side really helps to evaporate more waters using the evaporation technologies. So these are the tools we designed as a concept at the moment, but then it's still in the initial prototype. We're trying to find a more large grant to develop further. But as you can see, these three color-coded bins were the main things we really wanted to promote, and then extractions in the middles, and then another evaporate palettes, and then a series of tools that are required to do the paintings activities. So I'm going to show you how it works. Once the correct waste bin stored in the bin, and this can be used in art education settings, and help children to understand And then the result of the using our tool was quite successful in a way, even though it was the initial prototype. So this is examples of swatch we created by using our tools. We had a little issues with preservations, so we're still looking to solve those problems, because a lot of color has been degraded after a few months later on. But then some like vegetables and waste, like beetroot, kind of remained quite a longer time of preservation. So we also need to understand what materials works better for producing using our tools. And then we conducted a case study to introduce our tools and also method and the pigment we produced. And we visited, collaborated with Blacksburg Middle School and bringing in our tools, and also taught a little bit of our process to how to produce pigments from the food waste. So what we did was we installed our tools in the Blacksburg Middle School cafeteria. So this is Mr. Lee. He's an art teacher at Blacksburg Middle School. He's helping us to install this bin. So it's been there for like 2 days to collect the waste and help kids to understand of colors important to sorting when it comes to pigment makings, and which type of pigment and food waste we're collecting it. So you can see on this infographic on the bin itself, it tells you what we are collecting at that time. And then once that's been collected, we transferred to our office, my office, and then we had to wash them, because the loaf has got a little bit of salad sauce got attached to it. So we need to wash them and make sure the pure resources available to transform into pigments. And then we boil them through using a boiling method, one of our tools we created. And then evaporated more water through the evaporation technologies. And then we brought all this concentrated, more like a water paste format pigment into art sessions for them to really paint and mix with gum arabic and learn about the this process. This is the process of making their own paintings, mixing with gum arabics, and then some of the examples of their paintings are really creative. They kind of like go out of the box. So even though we provide worksheets, they really enjoyed making pigments out of our provided the materials, and also experimented themselves. And then Hiromi is going to talk about a little bit more about our outreach activities.
Hi, good morning. So we went to many places, huh? And for example, here you are looking at that Wonder Universe at the Christiansburg. And we did all these, as you can see, vegetables and materials and presented to the kids, and they really enjoyed making paints. And these are the results. That's amazing how they can create with their mind. And also, this is like a science festival. This is science festival at the Art Center. And also, we went to the Pulaski Art Center and hockey for a day. The reaction from the kids are so fantastic. They enjoyed and they wanted to make paints with hands, and it's kind of like magic. And it's really fun to see them having fun. And a result of this research was quite successful. Students were engaging and they enjoyed the process of making pigment as magic. And 90% of the students and kids understood that food waste was very valuable. And also it helped shift the negative perception about food waste. That's important. And kids wanted to share their painting with parents and teachers. And they wanted to learn more about making paint at home and explore different resources for pigment making. And this is another exhibition at the West End Hall. And this is Avery Gendel, one of the graduate researchers, is experimenting with pigments, mixing baking soda and vinegar for color variations. And it's interesting because pH differentiation as alkaline and acid really changes the hue of that same ingredient, same pigment as well. And it's amazing to see those. And this is another art piece from the Ben Kirkland's painting, who is one of the ID faculty, which is like design, industrial design faculty. And we created some paintings using those pigments, and with Avery and so-called Spirit of Earth. Another painting about the endangered plant in Virginia. And also we did Virginia Tech Fall Festival this fall. And also we went to the YMCA Healthy Kids activities, and also students very involved in teaching paintings with their attendants as well, with food waste pigments. And also we expanded from the kids to the adults, and this is Amazon art center, not art center, art corner. Yeah. These are all like the Amazon people, Amazonian they say, but Amazonians are working on that paintings, and these are the results. Where is Evans? Hey, Evans. Evans helped us to create that handout prints as well. And also we went to Torpedo Factory, and we did 2 years in a row. Yep, so those are our outreach activities.
And then our findings and insights it's been published in a conference proceeding and Design Research Society, so you're welcome to find out more about our research. Another journal paper has been produced from Design Journal as well, so it's subscription-based only, but then still you will be able to access the paper online. And then our project was featured on WDBJ7, so I was fortunate to go there and interviews about our project. And then we got a lot of attention from the design journals, design magazines, so it's been featured in the Dezines and other small design online company. They wanted to really interview about these toolkits and the whole process of our makings and how we approach to these problems. And now we're kind of expanding this project into more textile organic dyeing. So how can we use these wasteful materials to use to dye textiles and not just only for watercolor paintings. I think that's about it. Yeah, thank you.
Thank you so much. What questions do we have?
Hi, thank you. I also love this project and seeing it in the Science Festival last time. It was wonderful. I wanted to ask your goals. Is it to help us be able to make paints at home, like having a kit or a method, or is it to produce something that was created from food waste and then they can get the paints from you somehow? Yeah, thank you.
Thank you for the question. That's a really good question. Yeah, I think at the moment our skills are more looking into informal learning settings or educational setting like art class, and we can provide or design educational tools for more accessible and more safe way to learn this process instead of using expensive and very kind of like safety required procedures and lab equipment. So how can we make it more accessible and kids have a better understanding about where the resource is coming, and that could transform into actual pigments, and then that could be used as a painting class. So we're actually more looking into more educational setting for now, but maybe in the future, if all the tools become more affordable, hopefully it can be manufactured and we can be more accessible to like home or like a small, like a family kind of like more size might be ideal, yeah.
Thank you. My question, I think, dovetails on the end of your response there. When you were working with the kids, did they resonate with the food waste message? You know, did they afterwards reflect on like what happens in their cafeteria and where everything goes? So what was kind of the environmental sustainable impact on those kids?
They actually more interested in the what materials are able to produce pigment than because we can only find out the like their intention to change behavior is by asking a question whether willing to do this or not, right? Because behavior change will takes time to understand whether their behavior changes happen or not. So we did a lot of surveys to understand whether they want to change more recycling food waste, and definitely more than 90% of kids said, yes, I am going to recycle more. And then obviously there's some students say, oh, I don't see any value in there, I don't like this idea. And obviously there's a negative, but then 90% of students sees more positive impact on recycling, and they sees more of the value of the food waste itself. They never thought about before. So before they thought food waste is just a waste and just discard it and then that's the end of the life. But now they see there's a value and then create some new source material that can be used in their part of their education or paintings or whatever the other part of their life. So yeah, only we did like surveys to understand their perceptions, if that answers your questions.
I had a quick question. So first of all, I just wanted to say thank you so much. The research project is amazing. I love all of the impacts that it has. I'm really interested about this textile application. Have you looked into, I think this is amazing and a great alternative for especially what's used in textiles now. Have you looked into how these dyes might fade or a way to kind of preserve them through, let's say, like washing clothes and things like that?
That's another good question. We're kind of actually in process of was experimenting with textiles. So I mean, I think Hiromi can take some of the answer, but then it definitely fades, and like in watercolor painting, so we really need to find a way to make some like longer preservation. For this project, definitely preservation wasn't really our key factor to consider because of these kids' paintings. It's always been thrown away. But then when it comes to textiles, it's definitely we need to think about it. But Hiromi did a little bit of more experimental with the natural dye. So do you want to?
Okay, well, so we extended with experimentation with the public, and we collaborated with the Engagement Center of Creative Aging here at the Wallace Hall, and we did workshop. And anyway, the long story short, still it fades, but also we can get whole variety of colors and as a dye, and we can dye fabric and yarns. And so right now, the problem is the preservation, light fastness of the pigments at this moment. Thank you.
So we have one online. Good morning, Carl. Is there an opportunity to turn this into a natural history lesson, as well as by finding additional colors in nature? And have you investigated finding yellow or blue pigments elsewhere? Is there an opportunity to turn this into a natural history lesson, as well as finding additional colors in nature? How might we find yellow or blue pigments? Those are hard ones.
Thank you. So actually, this presentation, I provide this, it's kind of like a guest lecture to design history class. So students learn about how olden times create the paintings using the natural resources. So it is actually already been used as a kind of lecture content in a design history compulsory class within our College of Art and Design and Architecture. I'm sorry, Architecture, Art and Design. And also we, for the textile dyeings, we kind of expanded this, not just looking into waste only, but looking into natural resources in Appalachians, what resources are available. We can actually collect them and like experiment to use for the natural dyes. But I think the project itself has many potential to expand, not just the food waste, but then like discarded many of the natural resource that's been out there, and especially in this area, we're privileged to access to Blue Ridge Mountain, so there's definitely potential we can expand it.
Black walnuts.
And walnuts, yes.
Heading your way.
Thank you. I didn't pay enough attention when I was a kid when Mr. Rogers went to the crayon factory, but is there a pathway to turn these pigments, capture them in wax and make crayons? I don't know what that process would be, but do you have any thoughts about that?
Wax. Oh, we haven't tried that yet. We can talk later about that.
Light fastness and all these things always like depends on the UV light and also like moisture and all these like external the effects. That's why like the cave paintings are all preserved better than the art piece outside. So maybe wax might be an interesting idea to just like the coat that pigment.
Yeah. We can definitely expand and like try other. And I heard like honey, it's good material for preservations, and other like natural resources are available to experiment it. So, but yeah, thanks for that.
As we close out, one last question. Can you all talk about, you're from different disciplines. Can you talk about your disciplines and how you folded those together in this project?
So I'm an industrial designer, so I am interested in more of designing a tools to facilitate this process, and designing a tools that's more accessible and portable. And I would like to have because we're getting a lot of call and like requests from different regions to hold the workshop sessions to teach them how to do this, like transforming the waste into a pigment itself. And my aim is to provide this kind of like portable tools with instructions, and they can run this program themselves independently without us being there, and then they have an agency to teach them their own kids within their own community and spread the word. That would be my contributions.
What can I say? I'm an artist, so kind of like I'm a free radical thing, like running around and like the bump into the wall and then fall down. Oh, okay, I have to change the direction and then again like run around and things like that. And the collaboration with you is fantastic. And somehow like we have freedom to try out. And you gives me this like all these materials to play with, and it's fantastic.
I love it. Well, thank you so much. We are at time. We always promise to end on time, so thank you so much for being here this morning. Thank you for sharing your work with us. We will not have a play date next week because I hope you all are celebrating the holidays. We will be back again the Friday after that, though, with more pastries and coffee, and we hope to see you then. Have a fabulous break. Have a great day.